back. And here we begin. So this is how our heap looks like. You know that you have flags to actually take care of: XMX, XMS, and XSS, which is the flag for setting the thread stack size. Okay. Now, when will GC run? That's first question that we'll try to answer. What is various collection? Because they are saying that they're minor, major, and sometimes even full collection. And yeah, I'll try to answer that very, very briefly. And what you can do to tune it. So first of all, you need to know that Java has generational garbage collection, because they did a number of studies in the 80s, and they actually came back with the hypothesis, empirically proved that most of the time when you allocate memory for your variable, either of the two happens. Your variable is very, very short-lived, as in it dies as an infant, or it actually reaches a very, very respectable old age. So you have generations. Either you have infants, which die very often, or you have seniors, which live for a long time. So with that in mind, they actually divided the heap for hidden and tenured. That is not the true division, because there is actually survivor spaces over here. Still, hidden is where objects are allocated. When you cannot allocate an object, then you have a garbage collector run, the minor collection so-called, because it actually tries to run over here. The minor collection very often becomes a major collection, which then runs not just on the hidden but also on the survivor spaces. If this cannot help, or if the connections are leading to the tenured, then the full collection happens and your garbage collection is going through an entire heap of your JVM, there and back. What actually happens when you allocate and you cannot allocate because of, say, memory partition? So this is where survivor spaces are coming in handy. So let me again ask for several volunteers. Guys in the back, please, I invite you again, I miss you. Come over. And also guys on the left, please, come over. So that they will not be alone this time. Guys on the right. Thank you very much. So please, if you could stand in a line front to the audience. All right. So let's say that we actually, please, one continuous line. We have allocated this many objects, okay? And now garbage collection happens, and some of them turned out no longer to be needed, okay? So let's say that you're free to go, and let's say that you're free to go, and let's say that, I like you. You're free to go. Not that I don't like you, but... So we have now empty places in our, please stay as you are. We have empty places in our memory. Now let's say that we have some really large and imposing object to be allocated. I can think of only one person. Yes, dear Frenchman, please come over. With your incredible presence, only you can fill this role. So we have Nicolas, please, ovation. Now then, Nicolas, if it would be a true French object in the memory, that would happen. Unfortunately, this cannot happen. This cannot happen because Nicolas is too big. So he doesn't fit here, and let's say that this over here, right after Maciek, this is where Eden ends. So all of a sudden, we need to allocate him, but we don't have the place. So what can happen, and think of him like, for example, an array of objects. Oh, thank you. So what will happen is that he will be moved, actually. So in order for this not to happen, because moving him to tenured and allocating him there is a very bad idea for a number of reasons, guys from who worked on visual or virtual machine, they actually came up with a very interesting scenario. They added, after garbage collection, repackaging. So there is a survivor space, and everybody, if you could actually start from here and group yourself again in a line. When garbage collection ends, survival space gets filled, and now we can allocate Nicola because we have Eden space cleared out. Okay? And this is why survival spaces are needed. Then another garbage collection, when it happens, we will move guys from here and from here to another survival space. And survival space which was used will be freed, and Eden will be freed. So in a nutshell, that is why survival spaces are needed, and they are complementing Eden to actually have a younger generation together. But in case of really large array, it may happen that the space we have in a survival space is not enough. And then, unfortunately, he is promoted to a senior outright, and off you go there where there is a lot of space, and you will fit there. Yeah? Which may happen, and if in the tenured space there will be no place for as large array as Nicola can represent, oh, thank you, then we will get another flavor of out-of-memory error. Now guys, thank you very much for that. You're of course free to take yourself a batch and sit down. So survival spaces are created so that we can avoid memory fragmentation. Because the fastest technique to allocate memory is bump the pointer. So we want to start from the very start of Eden space and bump the pointer to actually point out here is the place where the new object is allocated. Okay? So, with generation garbage collection somewhat decided and described, let's move on. Oh, I actually blocked my pointer. And you can tune this process. There is a number of flags which can actually take the space of the Eden compared to the entire heap. They can actually give you the ratio of the survival space compared to the Eden itself. So for example, you can say that it's 1/4 or 1/6 of the Eden, that will be the size of survival space. And you can set up how many promotions are required, so how many garbage collections need to happen when before your object is promoted to seniority. So these are very good mechanisms for you to use in your applications, okay? To have it working with these things in mind. Because if on occasion you will find yourself in a situation where your application creates objects which are neither infants nor seniors, you're in great trouble. Because pretty much garbage collections start working against you every single time it happens. Okay? You want many junior objects and you want not so many senior objects. So this is why you have the sizes of the survivor spaces. This is why you have actually the number of promotions. So you can tweak that. So this will fit your case. Okay. If you want to play with that, garbage collector logs are necessary. So I think everybody with the laptops by now should have the materials, right? So my first question or request to you is try to run the Java 2D demo that I've given you, and try to run it with 10 megabytes of heap. Okay? So set XMX to 10. Try to run it like that. You guys have the materials? That's not it. Here or here? Pick your poison. Yes. Java 2D is the directory. Let me walk. Yeah. 10 megabytes. Try increasing. Oh, not MB.
M?
M.
M also.
Now try increasing. And you may actually, yes, that is a very nice example. You may want to switch things around.
Okay.
First, the JVM parameter.
And before jar?
Before and also without the equal sign.
After all stuff.
Yeah, but with the equal.
It could be ignored, I guess.
Yes. So first thing that you will learn is that order matters, okay? You're running a jar file. If you do this in the wrong order, the parameters will be ignored. Also, the XMX doesn't use the equal sign that you may read in the documentation. So if you're using, for example, XMX equals something, that will not work. All right. For people who do not have laptops, you're left with enjoying my miserable skills at command line. So, where did I put it? I think it was here. No, here. And is it? Then it would be szkoleniowe JVM. Yeah. So this is the command. Can you see? Oh, you can't see, obviously. Sorry. One moment. Oh hell, this will be surprisingly hard. Wait a second. Now then. So this is the application once I run it, and if you want to take a look at how it the guys over there have two sorry. So once you run it, I would like you to go to, oh damn it, let me move. Sorry for turning my back on you, but otherwise I'll be hard pressed to manage. So I would like you to go to transformations, and here I would like you to increase this and this to the very, very right corner. And also take a look at here the memory monitor, and you can see how it's rising, okay? So if you launched it from the console as I did, which looks kind of like that, if you specify the jar, then you need to follow with the name of the jar. Okay? Otherwise, the arguments will be ignored. Now, tell me, do you think that it's actually relevant whether I put it here or before the jar? Exactly so. Thus, this command, while it launches the application and gives you no mention of the error, is not correct. Okay? So, let me break it down. And let me rearrange things. I've eaten an X. So, we're now starting the application, and we get something really interesting. So let me let me move up. Yeah, error loading image, out of memory error Java heap space. Now, please try to find the minimum amount this application needs, minimum amount of memory this application needs to be launched. Okay? Vladimir, why don't you do it on my laptop? Because I could feel your eyes on the back of my... So here, please remember that you will be doing it there. If you don't want the tmux, I can kill it for you. If you press enter, you land on the end. Feel free to do Ctrl+C to kill it, because right now your application is running in the console. You can launch it with 15, but not with the 12. What's your system? Java 8 and the Mac. Okay, so 15 for the Mac, but not the 12. And now you've noticed something really interesting, okay? It changes per system, it changes per laptop, it changes per JVM, okay? So I had people launch it on a Mac with no less than 20 megabytes. If they given it 19 or 17, it would not launch. It is still the very same application because I'm giving it each time I'm actually having this workshop, okay? I tried finding the good answer for that, but so far I don't have anything other than the specifics of the operating system and giving the memory. But yeah, that's written with my finger on the sand. Yes, by actually, you're having 8 with which number? 101. So, okay, it is more advanced than the previous Mac user that he I think had 60. 1.8 update 60. Yeah. So, still, I must tell you, Maurice, that actually it's not 101. 745. 845. So, if I recall correctly, the previous user with worse performance, he had this update 60 for the 8. Yeah? Yeah. So, what is interesting actually about that is that even with the same JVM, I had different values. Okay? So far it seems that ThinkPads are the best for that. And on one ThinkPad, the guy actually managed to have only 9 megabytes where he ran it. And that was enough for the same application. So, just to run, yeah. When he increased it, when he tried moving it around, it crashed immediately, but without him touching it, it was able to work. Now, interesting case is, you may have been taught that once the out-of-memory error is thrown, because it's an error, that is it. JVM crashes and that's it. So you can actually see with this application, you can try running it, and you will see that despite occasionally throwing out-of-memory error, it will bounce back and it will work. And you will even be able to interact with it a bit. Okay? So out-of-memory error, as you can see, is being thrown right now in the back consequently. Also notice, nothing moves, okay? The application is frozen. The application is frozen because we're out of heap space. We're out of heap space, we're trying to garbage collect anything that we possibly can. So on those 9 megabytes, 9 was it? 11. So on those 11 megabytes right now, garbage collection is happening constantly, okay? Yeah. So that is one. Now then, let me do one other thing. And here we are. Yes, it occurs for the event dispatching thread, as you say. Excellent point to be. Because of the event queue, it might be as you say. It might be as you say. Still, very nice point. Let me reward you. Here you go. So, Maurice nicely pointed out that this application is actually AWT application. AWT has an event dispatcher, and event dispatcher may be able to be out of memory while still some other threads might be operating. So with that in mind, let me address that. Your application will freeze during garbage collection in its entirety. Okay? Every single thread your application has is a potential mutator thread, so it must be frozen. It cannot be left alive and kicking. So the only place for application thread to be left alone is when it's actually en route to save point. That's the only place when the application thread will be left alone, because the save point is where it can be frozen. So if you have a large for loop, for instance, and you're using wrong type of variable for it, then you will be able to see that some of your threads are still waiting till they are frozen. Now then, with something also interesting, guys, do you know how to obtain, how to actually find out the PID of your application? JPS, not JPC. JPS is one option, JCommand is the other option, and there are of course system options. Okay, so system options, let me run a couple of applications. Let me divide the screen. Add is that. Okay. Okay, so I'm running one application here. Where's my cursor here? Let me increase the memory a bit so that it will not crash. Okay. So now I'm running several applications. Let me open a terminal, and this is what JPS command will do. Okay? It will tell how many Java processes I have on my user. Okay? If you want this to actually pick up Java processes started by different users, you will be hard pressed to do that. Because what it actually does is, I think it was TMP. Yeah. Okay. So when your JVM process starts up, in the TMP highest path data, your username, it creates a directory with the PID. And in this directory, you will have the option of actually asking the JVM for various numbers. And JPS is actually doing a lookup in this directory. So if JPS ever comes out empty, like if JPS is never telling you what it is supposed to tell you, first make sure that this directory was actually created and that your user has the permissions to read it. Because if you're running JPS without that permission, it will come back empty. That is one. Number two, take a look at whether some specific variable, I think it was io_temp_dir variable on the Java side, is set to this directory or something else. Sometimes, for some reasons, like for example working with lots of documents and needing a temporary directory with lots of space, you will actually change that variable. If you do that, then instead of temp highest path data, you will need to read some other directory, and perhaps you don't have permission there. Finally, if JPS comes back empty and you've actually ruled out those possibilities, what you need to do is actually to take a look at whether you are running those processes as your own user, because as you can see, this is per user directory. So you will need to run the JPS as another user then. So sudo, su, commands like that will be handy. Now, JPS has options, okay? Because you may say, but we are only getting like the PID and the name. So JPS has options, as in JPS -L, for instance. And now you can see that we're getting the full qualified name of the class, okay? So here we only had remote Maven server, here we have actually the full launcher, okay? And I think JPS -v was also, which gives you pretty much everything. This is the entire command line which was used to run these applications. Now, JPS is very handy because usually when you do something like that. Okay, ps grep java. Sorry, the ps minus ef or aux. Yeah, and now you have it, which is less readable. Okay, if for any reason JPS is not working and you can't get it to work, and if you show this to your system admin person or your DevOps person, they will do, ho 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 ho, you noob, it's not how it's done, because there is this command. Yeah, and you can actually run it like that. Which is nice, and you can then reply, ha 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 ha, you noob, because there is this command. And J command is something that may have an advantage over JPS. JPS is labeled by Oracle as experimental, meaning it can disappear. To be honest, I haven't checked if Java 9 has it. Okay? But for example, Java JHAT was actually labeled as experimental, and Java 9 removed JHAT. Okay? I didn't see that they removed JPS, so I'm betting my money that it's still there, but I haven't checked. J command, on the other hand, allows you to get a PID of the process or to send a command to the process. Okay, so you can send an arbitrary command to those processes that you have listed here. Okay, so now you know how to get the PID of your process, which is fairly important because our next exercises will be about getting the threads of the processes. Okay, so I want you to tell me, I want you to launch your Java 2 demo application, and I want you to tell me how many threads is it running. How to do that? So you can tell it with PS, to be honest. If you do man on PS, you will find -o option. Yeah, -o option allows you to actually run it with your own format. Let me go with, yeah. Do you see it on my screen? So here, let me leave it here for a moment, and I would like you to take a look at that, and I would like you to come up with a PS command which will give you the sub-processes, the lightweight processes of a given process. So you will be running PS with a PID of your Java 2D application, and with -o, and what I want to be printed out is the lightweight processes of this application. Okay? Yeah, I can use mission control, but actually my first solution to this problem before I even learned mission control was the script. So that's my take on it. To be honest, I don't feel proficient with mission control enough to teach it, you know? That's the point. Oh heck. I would say try Task Manager to see if it will list threads, because, oh hell, Windows. I don't know even if the threading is similar to treat it in the same way, you know? So, yeah. So let's have the PID, and we have the PID, for example, 133.0.0, 133.0.0. Let me introduce you to another very nice command, but after you have the PS. Wanna try the PS on my laptop? Come on, don't be shy, Vladimir.
I also use Windows, but
You're using.
I have
Try. I think it should work. If it has the PS,
and anyway I have PS, so I can run Java from here and
definitely should work. Try first man, because if you scroll down to -o, you will find various options. and some of those options will be very useful. If you want to search in a man, press the slash -o, enter. Now lowercase n gives you the next match, and uppercase N gives you the previous match, so you may jump with it. Okay.
It's not much information.
Yeah, but there should be options for it. Next, 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 next. Oh, here there is CPU, there is mem, and there are flags. Oh, wait, I think here additional characters, that is the state. Okay, scroll down, you are right, after the keywords. So CPU, short-term CPU usage, locked name, mage name, nice. PIT is the process ID, and ppit parent process ID. Scroll down, please. Thank you. This is definitely helpful. There's TTY. Oh my. It seems I actually over-evaluated one, but I'm sure I found it here. Nevertheless, apology, because we're running out of time. Let me so this is the line over here. Let me highlight it. Here. Okay. So what this actually has is you need to replace the $1 with the PIT of your application, and this will give you the lightweight process and the CPU usage for the given PIT. And Bożidar, I believe that's the answer to your question. Yeah. So now, if you do that, you will obtain system information about threads. And if you run JStack on a PIT, you shall obtain Java information about thread. Okay? So, if I run this application on our app, I'm getting this. Okay? OS data. This guy is using 5% of the CPU. Java data, it's event Q0 and the name. Waiting on condition. What is it, Maciek? Sure. Oh my. Now then, I think it would be, don't go there. Oh, really, I hate navigating with the mouse. Let me choose, say, this one. Yeah, this one. Okay. Close. Doesn't seem like it changed much, now did it? Since we have only a few minutes left, let me instead highlight it for you, okay? I'll remember though next time. So, like that. So what happens here? I'm actually selecting data from PS and I'm actually running JStack. Now JStack will give you information about the thread like name and thread ID and NID. NID is like that, okay? The hidden trick here is that this is actually the hex and this is the decimal. So the only thing you need when you do a stack trace and thread dump with the Java tools, you need to take a look at NID and actually convert it to a decimal number. Once you convert it to a decimal number, you may look for this process ID on your system. For example, with PS, for example, with ls-prots and other tools that you have at your disposal, top, htop, whatever it is. Okay? Now then, going back to our slides for a few more moments, GC logging. If you want to log GC, it's actually a fairly simple manner. So let me go back to one of my applications here. Let me stop it and let me run it with additional parameter. Okay, what I'm typing here is log GC flag with the file name. Okay, now let me open this. This is ADZ. Here, and over here you can actually see a log. If I open my terminal, go to that directory, now you can see the details of garbage collection. So don't grow too attached to this logging, because this logging will change with Java 9. Okay, there is a JEP in place, unified GC logging, actually unified logging for the whole platform, and the logging will change. Honestly, I'm not so proficient yet with the changes to tell you exactly how, but this log format is actually consistent for Java 8 and Java 7, and I think Java 6 as well. You can find something similar on other JVMs, so this is actually the part that will work even if you have IBM JVM or JRocket. And what you see here is the COS, or the type of the GC, full GC, what caused it, like allocation failure or system GC call. You can see the parameters, like how many seconds it took and how much memory it freed. The exact state of this with the columns you can find with man. Okay, so man Java, man JStat, man JStack will give you the additional information along with what is the output of those commands I'm showing you today. So just with that, you're actually able to log your GC. So my series request number 1, which I actually set over an hour ago, once you come back, try to have this incorporated. There are a few flags which you need to actually take into place when you log GC, and they are the file, actually the logging, then the timestamps, and so on. There is an excellent blog about GC in All Things GC. It's actually Alexei Ragozin, and the guy is having incredibly well made of PDF with all flags that deal with GC logging. So there you will find all flags that you need, many more than I just showed you here. Okay. No, there are manageable flags, but verbose GC is manageable. Logging GC is not. So if you want, you may actually make your application spill out GC logs to the console, if it didn't, with verbose GC, but you may not change the logging GC. Okay. How much the logging affects the application? Not enough not to do it. Okay? There is always this question, but let me ask you a different one. how important is it for you to know how much time your application is spending on GC that is not doing the work user wanted to do versus not knowing it? So my answer is exactly the same. Yeah. All right. So let me stop that. Let me go back to slides. Where are you, my slides? Oh yeah. Nope. Here, I think. So log GC, please. And remember that this is a trade-off. Whenever you want to switch to a different algorithm for GC, you will need to actually remember that this may work for you, but this may not. It depends very much on your application. The first thing you need to know when you're asked to tune GC is what your application is supposed to be doing, what is the peak hour, or how is actually the traffic versus the shape of your application, and then what are the logs from previous GC tunings, when GC is happening and why. Okay, so these two people, Heinz Kabutz and Kirk Pepperdine, came up with the methodology called the box. So you begin with the traffic, you then move on to what is your integrations, what other systems are knocking to your application, perhaps causing the spike in traffic. Why is this important? Case A. My friend, system admin, actually spent 3 weeks looking for a problem with the application because the customer reported that every 9 AM it had a peak. And my friend was looking for the cause. Only to later learn that the customer was Japanese. Japanese people are very serious about being punctual. So 9 AM everybody logged in. Inevitable. Yeah? Case 2. My customer killed my application. How? They said, we're actually having a promotion. Come, log in, you will get a bonus if you log in today, use our services. We had a DDoS because they never bothered telling us that on this very day they are having such an action. So traffic was 3 times as large as we expected it. They burned through our margins and we crashed. So it's important to know who and when is using your application. Application code is the next. How you're actually doing. Your threads, your algorithm, your data structures. These are the key things that you need to know. Then you're going with the JVM. Flux GC. This is what we were actually covering today. Then operating system, which is file system, ulimit, config, architectural, other processes which may eat your resources and interfere with your process. Virtualization, which actually we will not cover on such a short notice. The other thing that is very, very helpful is use. This is Brendan Gregg metric, usage, saturation, and errors. So let's say I'm a resource and you all want to actually get my knowledge. So you guys, you may actually benefit from this, but I'm limited to actually reaching to some of you. So my usage, for instance, is just the front row. So they are actively using me right now and I'm giving them my knowledge. But you, the other guys in the back, you are waiting. Because I'm strained, for example, I'm starting to cough. These are errors, okay? So now transfer this in the technical jargon. Let's say that you have CPU. Processes which cannot get CPU time are waiting. This is the queue, okay? Processes which are actively using CPU are the usage, the utilization. So utilization, saturation, those who are waiting, the queue length, and then errors if CPU starts to behave weirdly due to actually overuse, okay? So have a list like that for pretty much every important resource in your system. Be it a database, be it, I don't know, connection pool to some other system, be it allocation of new objects or anything like it. Once you have the checklist, you can tell the condition of the resource very, very quickly. You're executing 3 scripts, one for usage, one for saturation, one for errors. And you know, this resource is in green condition, this resource is in yellow condition. So the box and Brendan Gregg. Linux tools, okay? This is actually also taken from Brandon's Greg blog, and there is not a single place in your system which you cannot look at with GNU Linux tools, okay? You can look at fans. You can take a look whether your fans are actually rotate in an appropriate speed or not. You can take a look at the temperature. You can take a look at VM or virtual memory. You can take a look whether your I/O system is behaving well or not. So really, GNU Linux definitely has a tool for that. And there are also profilers. One profiler which is nice and is not included here is DIG, D-I-G. If you want to start with one tool, start with SAR, System Activity Reporter. If you enable SAR on your production box, it will actually store all the events that happen, and later you will be able to ask it questions. It will tell you, well, this is no different than the behavior 3 weeks ago. So no, you're not looking at anything strange, okay? So there is surely a tool for that, and Java process we have covered already, so I'll finish with that. Thank you very much. I'm hoping that I actually shown you some tools. I've told you a bit about garbage collection, though we didn't cover algorithms, we didn't manage to. And that is it. I'm open for questions. Sure. Excellent question. Here. Pass it on to the guy, please. And pretty much every single tool I was showing you is something that you're able to script, okay? So no matter what kind of monitoring solution you have in place, is it, I don't know, Grafana or Kibana from Elasticsearch or anything else, you're able to actually feed it with that information, okay? Just repeat running of the script periodically and have the output being fed to your monitoring solution. Be it Nagios or Zabbix or whatever else, it's capable of actually taking such inputs and putting it somewhere on the graph. So you will be able to actually have it actively going on. There are obviously solutions for active monitoring which fall under APM category, which is Application Performance Matrix or monitoring. And solutions like that are the famous AppDynamics or New Relic or Dynatrace. These are the 3 leading solutions, okay? Each one works with Java applications. AppDynamics is notably more forward, but if your app is a web app, I would actually go with New Relic. And lately in, I think, Latvia, I had a talk with Dynatrace guys, and they told me that recently their tool beats the other two when it comes to performance. So, Božidar? How would you crash a Java application? Traffic. In the right way. So there is this evil system and it runs on Java. Mm-hmm. I would first try to add one flag to the application. I think it's a manageable flag, so that should be doable. That would be heap dump on out-of-memory error. So if that's done, then probably with the heap dump, you should be actually exit. You should actually, this should actually crash the application. It often does. If it doesn't help and the application is not running with XS, I think XRS, then I would send a signal to it with kill. So I would do a kill -3 for starters or kill -15. If this still doesn't help, I would go for really -9 from the operating system side, yeah? If you really want to crash it. Yeah, so I would leave -9 for the very, very end because then it's no longer a clean exit. Okay, so 3 and 15 I would go first with them. If the application is having a console, kill the console. Sometimes the application is still hanging on, and then you can send kill3, which is the stop signal, and it should stop. Yeah. So that is one option. On the Java side, you can always try sending the command to it with J command. Yeah. So you can actually try this way. It depends on what the application is doing. I will choose the suitable option to actually close it. Yeah. All right. Thank you for the good question. You also had a question, right? You're a bicycle coder. Or was I wrong? Okay, so guys, thank you very much.